Hello and welcome to this video in which I will show you how you can generate a Scree plot for an exploratory factor analysis in the Mplus software. My name is Geiser. I'm an instructor with QuantFish. One thing that many people don't know is that Mplus is not only a great program for structural equation modeling and confirmatory factor analysis as well as latent class analysis, but it also works really well for exploratory factor analysis. It's a very flexible program that offers you a bunch of options that other programs don't offer, such as detailed tests of model fit and fit indices for different models, and the handling of non-continuous variables in an EFA. So when you have binary or ordinal variables that you want to factor analyze with an EFA, then Mplus is a great program because it has the right estimation techniques for that kind of data, and I show that in a separate video that you can find here on this channel, EFA with categorical data in Mplus. And one thing that people are confronted with when they run an exploratory factor analysis is how to determine the number of factors. And so one thing that many people like to look at when they run an EFA is a Scree plot of the eigenvalues, and that shows you then the distribution of the eigenvalues across the factors, and you can see how many strong eigenvalues you have, and that might give you a hint as to how many factors you should retain. Now, how do you get such a Scree plot in Mplus? It's not totally obvious. There's not an option that says Scree plot, but instead it is provided when you specify the plot option with type equals plot2, like I did here in my EFA example input file. So when you include that plot option, then that plot2 will automatically be the Scree plot. Now, Mplus does not only give you the Scree plot, as we will see, but also allows you to run a parallel analysis, which is an even better method for determining the number of factors in EFA. A Scree plot is kind of subjective, and it's sometimes really hard to figure out from a Scree plot alone how many factors you should retain, because it may not be clear cut where you find the Scree, so to say, at the bottom, where really the Scree plot flattens out. That's not always super clear. But with parallel analysis, you have a somewhat more objective criterion, because in a parallel analysis, we also look at the distribution of the eigenvalues for a set of random data. Now, what does this mean? Random data or random variables should only correlate by chance, because when you randomly generate variables, they really shouldn't have any meaningful relationships beyond chance. However, due to chance alone, or we could say due to sampling error, those random variables will also show some correlation that is non-zero. So that's a chance correlation. And then as a result, there will also be non-zero eigenvalues that can be extracted from a correlation matrix of random data. And so that is a good baseline condition to compare our real data eigenvalues against, because really this provides a baseline for what is a meaningful eigenvalue, and this can help you determine how many factors you really should retain when you compare the Scree plot for your real data to the Scree plot for random data, and we will see that how that works here. Now, how do you get a parallel analysis Scree plot included in your graph in Mplus? You do this with a single additional line of code. Under analysis, you specify parallel and then the number of draws of random data that you want to use. So it's kind of like a simulation where we don't only select a single set of random variables, but we do this over many replications, in this case 1000, and then we average the results, and then that provides us with more certainty, because a single sample of random data could by chance alone produce correlations that are somewhat high or somewhat low. And so when we do this across many sets of data and average the results, then this will give us a clearer picture as to how high correlations would be, how high eigenvalues would be in random data. So here I chose 1000 draws or replications of random data sampling for the parallel analysis, and then automatically Mplus will include the parallel analysis eigenvalues in the Scree plot as well. So let's see what that looks like. I already ran my input file here for 6 variables that I factor analyzed. I chose an EFA solution with 1 factor and one with 2 factors that will be provided in the output. And so let's take a look at the plots, which you find under plot and then view plots. And then you can see for an EFA, when you choose type equals plot 2, there's only one option that is provided, and that is eigenvalues for exploratory factor analysis. So we click on view then, and you can see you get your Scree plot in red here. The sample eigenvalues provides the Scree plot for the real data, and that has the characteristic form or shape where the first eigenvalue typically is rather large, and then the next one is still somewhat large, but then at some point the eigenvalues become flatter. So you can see here that I could make a case here and say, well, I want to choose the first 2 factors here because then it becomes really flat at the end, but it's not extremely clear cut here where I should draw the line based on the Scree plot alone. However, the parallel analysis helps me because the parallel analysis shows me what the eigenvalue distribution would be over 1000 replications of random data, and that is shown here in the line that has the triangle. So the triangle line shows the eigenvalues for 6 factors that were extracted for random data as a comparison. And you can see that there are also ones here with eigenvalues greater than 1, even for random data, but these are all pretty flat. So this distribution, they're all pretty similar. And that's typical for random data, that no eigenvalue really sticks out here because it's just a set of random correlations. And so it has the characteristic almost linear distribution here, or linear curve. You can see that it cuts our real data eigenvalue graph right below 2 factors. So according to that criterion then, 2 factors are substantial because parallel analysis here intersects with our sample eigenvalues right below 2 factors. So we should retain the 2 factors that are above the line for the parallel analysis, those 2 here. So we would choose 2 factors, which also in this example does make sense. Now, in addition to the actual or averaged eigenvalues across the 1000 replications, Mplus also provides you with a parallel analysis 95th percentile. So that would be the most extreme samples out of the parallel analysis, where the random correlations happen to be pretty high and the eigenvalues happen to be pretty high as a result by chance. So that gives you a worst case scenario, so to say, as to how high eigenvalues could be according to a parallel analysis, and that's above that, and it's not much different. So you can see that really they were all pretty similar, those eigenvalues. Even the 95th percentile based on the parallel analysis is not much different from the average that is shown below that. So we would draw the same conclusion that 2 factors here should be retained. I hope you found this video useful to learn about how to create a Scree plot using Mplus and how to include the results of a parallel analysis in the Scree plot as well, which can be helpful to determine the number of factors. If you did, please subscribe to the channel and check out the description for additional resources, including courses on factor analysis and other techniques that I teach for QuantFish, and I'll see you next time.